Hi everyone, welcome back. Today we are solving prime number of set bits in binary representation. So in this problem, we will be given two integers left and right, and we want to return the count of numbers in the inclusive range from left to right that has a prime number of set bits in their binary representation. And a prime number of set bits just means a prime number of ones when the number is written in binary. So if we look at this example from 6 to 10, 2 ones is prime because 2 is prime. 3 is prime, 2 is prime, and 2 is prime for 6, 7, 9, and 10. Their binary representation has prime number of ones, so we will return 4. In this example, 2 is prime, 3 is prime, 2 is prime, 3 is prime, 3 is prime, but 15 has 4 ones, so 4 is not prime. So for this example, there are 5 numbers that has a prime number set of bits in their binary representation, so we will return 5. So now that we have seen some examples, let's get to how we can solve this problem. Now, one way that we can solve this problem is we can use the sieve of Eratosthenes. If you're not familiar with this algorithm, feel free to look it up first. It basically is an algorithm to figure out the number of prime numbers. So we will use this algorithm to figure out the number of prime numbers starting from 1 to right, and once we have that figured out, we will add it to a set, and then we will look from left to right, check the number of ones. If it's in the prime set, then we increment result by 1 and we return result. Now if we solve it this way, it will be Rlog log of R, because that's the time complexity of sieve of Eratosthenes. So there's actually a more efficient way to solve a problem, so let's go over that way right now. Now, I included a previous solution because I always like to solve the problem assuming we don't know the constraints, but the official solution on the Leetcode editorial does assume that we know the constraint, so I guess we can use that as our advantage to solve this problem. So we know that the constraint, the right, would be at most 1 million, so we actually don't need to spend our time calculating the number of primes. We know that at most it will go up to 19 bits because 2 to the 19th will be this, and 2 to the 20th will be over 1 million. So we know that 19 would be the biggest prime number that we would need. So what we can do is we can just directly set the prime set to all the prime numbers up to 19, which would be this right here. And we will initialize result to 0. And then we will iterate through all the numbers from left to right. And if the number has a prime number of ones in the binary form, and we can check that by just looking if the number of ones is in the prime set. If it is, then we can increment result by 1. And then finally, we can return result. So let's go over this example real quick. So first we will initialize primes to all the prime numbers from 2 to 19. Now we'll look from 6 to 10. 6 has 2 ones, so increment result. 7 has 3 ones, 3 is prime, so increment result. 8 has 1, and it is not in primes, so we don't increment result. 9 has 2, increment result. 10 has 2, which is also in the prime set, so we increment result again. And now that we come to 10, we can return 4 as our result. So the time complexity would be O of R minus L, where R is the right number, L is the left number, because right minus left would be the number of numbers that we will check through, and the space complexity would be O of 1, because primes will always be this no matter how large the numbers are, so the space would be constant. So now let's get to the coding part. First, we can initialize primes to all the numbers up to 19, which would be 2, 3, 5, 7, 11, 13, 17, and 19. Initialize result to 0. Now we will look from left to right. So for n in range left to right plus 1, and if the binary of n has a prime number of 1, so binary of n dot count 1 is in primes, increment result by 1, and then we can return result in the end. Let's see if it works. Okay, perfect. Thank you all for watching. Hope this was helpful. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.